Okay, y'all, this is the final exam review, Unit 9 for a pre-calc final. This is the 2018-2019 school year. So the Unit 9, when we did it, was really short. So this is only going to be 5 points for this year's final exam. A couple things to just notice is we spent a lot of time specifically on parabolas and circles. So you'll notice that this is about finding the vertex of a parabola. This is about finding the center, which we can actually do. It doesn't have to be for a circle. We can also do this for hyperbolas and ellipses. You're definitely going to have to classify. And then you'll notice on the back there's some graph matching. So let's do this. Depending on the form you have, finding the vertex can be easier or harder. So this is actually almost in vertex form. All I have to do is add 8 to both sides. And when I do, I now have it in vertex form. So the x-coordinate is going to be the opposite of what I see here. That's going to give me -9 plus 8. So that's my vertex for that parabola. Now in this case, this isn't in vertex form. I could complete the square, but there's a much easier way to do it. Remember the way we can find our x-coordinate. So the vertex is at -b/2a. So negative b is going to be -6. Sorry guys, my paper keeps shifting. Over 2 times 2, which is 4. So my x-coordinate is -3/2. Now, when Mrs. Barnes made this question, I was focused on just creating something that you had to use this formula for, and I was trying to make it so things didn't simplify, so I had a fraction, but I forgot that I was going to make you plug it back in. So this is a little bit gross. I would not stress about seeing something this gross on the test for the y-coordinate, but the way I do find the y-coordinate is by plugging in my x value. So I'm going to have 2 times -3/2 squared plus 6 times -3/2 minus 3. Again, this is going to be a non-calc test. You're not going to see something quite this gross. I'm sorry I threw that at you. But if I did have to do this by hand, let's just think about this. I'm going to square this, and that's going to give me a 9/4. Here, I'm going to have 6 times 3 divided by 2. So that's going to give me -18 divided by 2 is -9 minus 3. Well, this actually isn't too horrible. This is going to give me, so I can think about this a couple ways. I would prefer to say, well, I'm multiplying 2 and dividing by 4. This is the same as dividing by 2 twice, so I can actually simplify this and just do 9/2. Well, that's 4.5. And then I have a -12. If I simplify that, that will give me a -7.5. So my vertex, my x-coordinate was this. You can leave it as a fraction, but I'm just going to turn it into a decimal so that they're both decimals. Here's the big thing I want you guys to take away from number 2. This was numerically a little bit gross. However, if it's not in vertex form, we can find the x-coordinate using -b/2a, and then we find the y-coordinate by plugging in the x-coordinate. Okay? But don't worry about it being that gross. Okay, now we're going to identify the center of each. I meant for this to be a circle, but it really doesn't matter either way. This is actually just a parabola not written in standard, or a hyperbola not written in standard form. But I meant for this to be a plus sign. So if you want to change it to a plus, you can, but it really doesn't change the problem either way. It's still going to give you the same center, just a different type of conic. So when I have this, I should have the x-coordinate with the x and the y-coordinate with the y, and you'll notice there's no number in parentheses with the x. So one way I can rewrite this is by saying this is x minus 0 squared. And now I can identify the center easily. This has a x-coordinate of 0 and a y-coordinate of 4. These are in parentheses, so we take the opposite of what we see. That's why this is a positive and not a -4. Okay, this one's already easier. This one's the x-coordinate for the center is going to be 9, and the y-coordinate is going to be 2. Okay. Now we're going to classify. So in your note page in class, we actually talked about this. But let's just see if we can do a shortcut real fast. For a parabola, there's only going to be one squared term. For a circle, there's going to be 2 squared terms, but they're going to have the same sign and the same coefficient. For an ellipse, they're still going to have the same sign, but they're going to have different coefficients. That's going to cause like the x and the y to stretch in a different amount. Circles has to stretch the same amount in the x and y direction. So this is going to be the same sign, but it's going to have different coefficients. And then the hyperbola is easy to identify because the 2 squared terms are going to have different signs. So let's take a look. I like to use a highlighter for this. I identify my squared terms. I notice I have 2 of them, so it can't be a parabola. But I notice that they have different signs, positive, negative, so this has to be a hyperbola. For number 6, I identify my 2 squared terms. I notice that they're both positive, they're the same sign. They both have a coefficient of 1, so they're the same, so it's going to be a circle. Okay. Here I have my 2 squared terms. They're both positive, but they have different coefficients, so it's an ellipse. And then here I notice I only have 1, so we have parabola. Okay. We're going to write the equation of the circle. The only 2 things I need for writing the equation of a circle is a center and a radius. Well, I notice that my center is here at 0, 0, and here it has a length of 5. So if I want to write my equation, it's always x minus the x coordinate of the center squared plus y minus the y coordinate of my center squared equals the radius squared. Well, we can simplify this. This is really just x squared plus y squared equals 25. That's the standard way to see the circle equation. Okay, to the back. Okay, in these graphs, you're noticing that this is all hyperbolas, and we notice it's a hyperbola because that negative here. These are all ellipses. One thing we could do on the test is give you an equation, and part of it would be identifying which type of conic it was. But in this case, we're just identifying which one matches best. So when I look at number 10, I notice that I have my y term first. My y squared is positive, which means this has to open up and down. So the first thing I'm going to do is look, and I'm going to get rid of any options that don't open up and down. And again, I know that it's up and down because the y term is the positive one. Well, now I'm still left with 2 options. So I have a couple ways I can do this. I think the easiest thing to do is look at the center. So I'm going to identify the center of this, and I have to start with my x term, and the number that goes with the x term is 0. The number that goes with the y term is going to be -1, because that's what makes this 0. So I'm going to go into B and D and see if either of them have a center of 0, -1. So 0 and then down. That looks pretty good based on the center. And now let's look over here. This is 0, -1. Oop, that doesn't look good for the center. So my answer has to be B. So let's do something similar for number 11. Try to keep this all on the screen for you guys. I already know this is going to be an ellipse because they're the same sign, but you'll notice they have different numbers attached in the denominators. So the first thing I notice is that my A term is bigger. So A squared is bigger than B squared, which means A is bigger than B. That means it's going to open up long ways like this, not tall. So I can already get rid of choice D. So now I'm going to look at the center. I know the center for my thing, or for my ellipse, has to be at -2, 1. So I'm going to go through and go -2, 1. That's not the center. -2, 1. Oop, that looks like that could be the center. -2, 1. Oop, that looks like that could be the center. So the last thing that I'm going to look at is my A and my B term. So you notice A is 5 and B is 3. That means from the center, I should be going over 5 in either direction. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, they both are. And then I should be going 3 in the up and down direction. Well, this is only 1. This goes up and down 3 because each block is 2. So C has to be the correct answer. So again, on the test, I might not be asking, it might not just be a hyperbola equation with all hyperbolas. You might get like this equation, have to recognize if it's a hyperbola or if it's an ellipse and have a mix of pictures, okay?